Welcome back, everyone. This is chapter 56, and we're on to part 2. And what this section is really going to focus on is taking a look at how do we conserve populations. All right. And when we talk about population conservation, we've got to focus on populations from kind of 3 major criteria. First off, just population size in and of itself. How many individuals need to be there to ensure that the population is stable moving forward. And that's going to get tied then into the genetic diversity of that population, as well as what's the critical habitat. What does it need to look like? What does its size need to be in order to ensure that that population survives and thrives and is healthy? So when we focus on conservation of the population and the species sizes, they tend to take 2 different potential approaches. The small population approach versus the declining population approach, which is what we're going to go into next. So when we talk about the small population approach, all right, we're talking about looking at population sizes and how small does that population need to get to before it finally becomes extinct. And sort of one of the hallmarks to this particular approach is looking at what they call the extinction vortex. All right. And the smaller the population size becomes, the more susceptible it becomes to sort of these major positive feedback loops that kind of draw them into increasingly smaller population sizes and ultimately to extinction. And the 2 major loops or the major issues that we end up seeing in an extinction vortex is that I'm starting with a small population size, so there's not a lot of individuals there in the first place. They're probably cut off from other populations. And so you have this sort of interplay between interbreeding, so closely related individuals breeding with each other, and so you end up seeing negative traits become more and more common over time. And then you also have the genetic drift, where they're not getting replacement new influxes of genetic material. And ultimately, those 2 combined end up causing a loss of genetic variability, a loss of genetic diversity within that population. So from an evolutionary standpoint, what does that mean? That means that fitness of the population as a whole decreases. All right, and so the population's ability to adapt to changes decreases. What does that end up resulting in? You've got less reproduction, you've got higher mortality rates, death rates, and so it feeds into an even smaller population, and then this whole thing continues again, but now you're starting even smaller than you did up here. All right, and so really that genetic variation and the evolutionary responses that are tied to that genetic variation cause the population to continue to decrease in size until there's just no feasible way for that population to deal with any sort of change in their environment and ultimately become extinct. So the idea here is to sort of understand when does the population get so small that it gets kind of sucked into this vortex and can't recover. All right. And so some of the computer models that ecologists might use when trying to determine this are to look at sort of two pieces. So the minimum variable population size. So what's the absolute minimum population size that a species needs in order to sustain its numbers, keep its survival, and not kind of fall into this vortex. And then also utilizing the population variability analysis, predicting just kind of what population's chances are for survival over some sort of time frame, whatever we're utilizing to study. And most of these are different computer models that scientists go in, plug in numbers, but what they're really looking for is to determine if a particular study population is going to start getting sucked in to this extinction vortex, which means that we really need to ensure that our conservation efforts are being stepped up to stop that. All right. And one way that we can look at that is just trying to determine an effective population size. All right, so sort of estimating that minimum variable population that is required to determine what that breeding size population needs to be. Okay, and your text goes into some of this math. You can spend some time there, as well as taking a look at some of the case studies that are going on. But the idea really is that we need to ensure that you've got the right number of males and females to breed successfully, to keep the genetic diversity alive, to keep the population at a size that's sustainable, to keep it from ending up in this extinction vortex. So that's really kind of the take-home message for the small population approach. We can also take a look at it from another standpoint and talk about the declining population approach, where here the focus is more on populations that we already know are kind of threatened and endangered, but the population size doesn't really seem to have as big of an impact on this as it might in that small population approach. Okay, so here we're going to emphasize more on the environmental factors that cause the population to decline in the first place. All right, so we're already to the point where that population size is small, we're stuck in that vortex, and so now we're going to try and find ways to bring it back. All right, so here we're looking more at a much more case-by-case basis, although the small population approach is certainly that as well. That can be applied a little bit more across the species, just knowing what they need in terms of breeding behaviors, environmental conditions, where this one isn't even kind of species general. All right, now we're looking at individual populations and what sort of steps do we need to go in and apply in order to save that particular population within that particular area. Again, I encourage you to go through and take some time reading through the different case studies. They give you the woodpecker for the declining population, a little bit on the grizzly bear population with the effective population sizes, all right, as well as sort of the prairie chickens with the extinction vortex. So spend some time, make sure you understand kind of how these approaches get utilized in context by going through some of those little case studies that are mentioned in your text. Ultimately, the biggest problem with conserving species is resolving those conflicts that we mentioned at the end of part 1. All right, it's great to identify that this species is endangered or threatened, or we're getting close to that threatened point, and understanding the needs of those species in order to keep them from dying out completely. However, most of the time, the reason that these species are endangered in the first place is because of what we're doing as humans. And we can't just go in and say, hey, you've got to stop doing all of this, because you're putting people's livelihoods at stake. All right, the example there, the northwest of the U.S. And a lot of the conservation efforts are at odds with people being able to make money via the timber and mining industries. And as sort of a science-minded person, I'd love to say, yeah, we're just going to go in, we're going to take over, we're going to stop it, we're going to ensure that these species are protected and their habitats and environments are protected, and kind of be on that environmentalist side of things. But I also have to recognize that as a human being, people need to make money. People need to feed their families. and this is the way that they do it. So how do you manage the habitats and the necessities of these organisms while also managing the needs of the human beings living there? And that's not necessarily always a cut and dry line to draw. All right, I think a lot of you guys are going to realize as you continue to get older and understand more about politics and hopefully the science and just being an adult in general that a lot of things aren't black and white. All right, there's positives and negatives to every side of every argument. And I think if you're really effective in anything you do in life, you're able to see both sides and sort of manage a balance, compromise to both sides of the argument. And that's really where I think the most effective leaders are out there. So just keep that in mind. It's not just cut and dry. All right, you've got to manage everybody's needs as well as the environment's, and try to do that in the most sustainable way possible.